Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is the coordinate geometry. And in continuation with writing the equation of a straight line, we are going to take the second form, and that second form is called point to slope form. That is a situation where you have the slope of the line and you have the coordinate of 1 point on the line. So let's begin. After completing the very lesson today, my dear student, will be able to find or write an equation of a straight line using its slope and the coordinate of just a point on the line. This is what I hope you'll be able to do after completing the very lesson today. So as usual in your segment, Marcus Fund, today I'll give you another interesting property of that Pascal triangle. Remember, I keep saying the Pascal triangle has a lot of amazing and interesting properties. Today we are going to learn another property of the Pascal triangle, and that will be done after completing my lesson today, so don't go away. So to begin the lesson, let us see this form. That is a form where you have the slope of the line and you have the coordinate of a point on the line, and you are now requested to write or to find the equation of that very line. So let's learn that. So the equation of the line that passes through the point with this coordinate x1, y1. This is the coordinate of just one point that the line passes through. And the slope of that line is denoted by letter m is given also. So if we are to find the equation of that line, what you simply do, you make use of this very formula. The formula says y minus y1 equals to m into x minus x1. This is what we are going to substitute in this very formula, the value m and the coordinates of this point, that is x1 and y1. When you now substitute them, what you have in the end, after simplifying, you now arrive at the equation of that very line. We are going to make use of this simple formula to find or to write the equation of a line that passes through a point whose coordinate is given and the slope of that line is also given. So let us just move and take examples. Example number 1, it says find the equation of the line, and that line passes through this very point. Look at it. The point has the coordinate 2, minus 1, and the slope of that very line is 3. Solution to this very problem. What you do first is to write down that formula. So the formula says y minus y1 equals to m into x minus x1. This is the formula. So you now substitute those coordinates, that is x1, y1, and you now substitute the value of slope, which is 3 here. So let's move. So there, substituting y1, look at y1 is minus 1. So you have y minus minus 1 equals to your m, which is 3, the slope, into x minus x1. x1 is the value 2. Look at it here. So I'll now simplify this. Y minus minus 1 will now change it to y plus 1. Look at it. And opening this bracket 3 times x will give you 3x. 3 times minus 2 will give you minus 6. So you now collect the like terms. This positive one by the left, let's shift it to the right. So you now have y equals to 3x minus 7. Minus 6, after taking this positive one, it becomes minus. So you have minus 6 minus 1, which will now give you this minus 7. So this is the equation of this very line. Let's just move and take one more example. Example number 2, it says find the equation of the line that passes through these 2 points, and these 2 points, the coordinate of those 2 points were minus 1, 2, and the second coordinate is 3, minus 2. Solution to this very problem. So writing it down in the formula, y minus y1 equals to m into x minus x1. What is missing in this very question is the slope of the line. We have coordinates of just 2 points on that very line. Remember, in our previous lesson, we learned how to find the slope of a line passing through 2 points. So I'm going to use the coordinate of these 2 points to determine or to find the slope of the line. Then I can take any of these 2 points to be my x1, y1. So let me just find the slope first. So their slope is question mark, meaning it's missing in the question. So I have to find it for me to be able to use this formula. So let me just move and get to the slope. Slope, remember, it says changing y over changing x. So it's y2 minus y1 over x2 minus x1. Substituting it to determine m, I will now consider this point to be x1, y1, and this second point to be x2, y2. In that case, this will now be x1, this is now y1, and this will now be x2, this will now be y2. So substituting in this formula, I will now have minus 2, that is my y2 is minus 2, look at it. Then minus y1, and y1 is simply this number 2 over 3 minus 1. This is the value x2 is 3 and x1 is minus 1. So simplifying the denominator minus 2 minus 2 gives you minus 4. And the 3 minus, remember minus is plus. So that gives you 3 plus 1, which will be 4. So there you now have minus 4 over 4. And this simply equals to minus 1. So this is now the slope. What I'm going to do next is to go back to this very formula as I have my slope m, which is minus 1. I now take this point, my x1, y1, and now substitute in this very formula to find the equation of that very line. So substituting these values correctly, that is x1 by minus 1, y1 by 2, and the slope m, which is this minus 1. Substituting correctly, you now have y minus 2 equals to minus 1 into x minus x minus 1. So I continue. So I'll now simplify what is inside this bracket. The minus will now change it to plus. So there you now have y minus 2 equals to minus 1 into x plus 1. The plus 1 is the result of this minus 1. So I'll now expand this bracket by multiplying this minus 1 by everything that is inside. There you now have y minus 2 equals to minus x minus 1. It is minus 1 times x that gives you this minus x, and the minus 1 times positive 1 that gives you this minus 1. So I continue. So I'll now collect like terms. This minus 2 by the left will now be shifted to the right, where it will change it to positive. So there you now have y equals to minus x, which I just copied, then plus 1. The result of this plus 1 is nothing but minus 1 plus 2. The 2 that is here, which were a negative, after shifting it to the right, it becomes positive. So you have minus 1 plus 2, which gives you plus 1. And this is the equation of this very line. And with these two examples, I have come to the end of this very lesson. I hope you find it resourceable. With this few examples, I hope you can be able to write or find the equation of any line that has a slope m and passes through just one point, and you have the coordinate of that one, that very point on the line. So thank you for your attention, and let me just move to the last segment, Mercy is fun, and give you another interesting property of the Pascal triangle. So another interesting property of the Pascal triangle is says in a row where the second entry is prime. All other non-zero entries in that very row will now be divisible by that very prime number. Let's just test and see. So if I take this fourth row number 4, it is second number, second element, second entry is a prime number. Look at it, this number 3. So based on this property, or based on this statement, it says all other entries in that very row that are not 1, those entries will now be divisible by that very prime number. So the only entry not 1 is this number 3. This number 3 will be divisible by this prime number 3. Let's just do it and see. 3 divided by 3, of course, is 1, no remainder. Let me take this next row, which contains second number prime, which is this. Look at it. Look at it. The second entry here is prime. This entry, this row, that is the next row after this, contains 4 as the second entry, and 4 is not prime. That's why I jumped to this one. So based on this statement, it says all other entries in that row that are not 1 would now be divisible by this number 5. So 10 divisible by 5, yes. 5 is also divisible by 5. So I have 10 divided by 5 to get 2, no remainder. 5 divided by 5 to get 1, no remainder. Let me just take one more row that contains prime as the second entry. Here is 7. Look at it. 7 is prime. And it's the second number there in that very row. So based on this properties, is all these numbers 21, 35, and this number 7 will be divisible by this number 7. Let's do it and see. 21 divided by 7 is 3, no remainder. This 35 divided by 7 is 5, no remainder. This 7 also is divided by 7 to get 1, no remainder. So this is another interesting property of the Pascal triangle, which I believe you never notice. Even for those that know what is Pascal triangle, they never notice this interesting property. We will still see another interesting property of the Pascal triangle in our next lesson. Thank you for your attention.